Okay, today we're going to be talking about multiply matrices. Um, Now, to multiply matrices, we have to make sure a couple things line up as far as the rows and columns. So this little definition here kind of explains what that is here. So the product of two matrices A and B is defined provided that the number of columns in the first matrix A is equal to the number of rows in matrix B, right there. All right. If that lines up, then you have the dimensions of the new one are going to be determined by the number of rows in A and the number of columns in B. That's kind of wordy right there, so let me kind of show you a little trick how to see if you can even multiply two matrices together. And that's actually what we're going to spend most of today on. But today, right now, we're looking at, is it possible? So like it said above here, you need to go see if the columns from A, so remember it's always rows by columns. So rows by columns. So the columns from A need to match up with the rows from B. So if these match up here, this means you can multiply these. Okay, now if those match up and you can't multiply them, the result is going to look like this right here. The result matrix is actually going to be a 3 by 2 type of matrix right there. Okay, now like on this next example here, if these numbers don't match up, if the column from A doesn't match up with the rows from B, you can't multiply these. So you don't even talk about a result matrix in this case here. Now, the order of multiplying the matrices, that can change as far as if you can or cannot multiply them. So you'll always have to, kind of keep that in mind as well. So here's how to multiply matrices, and it's kind of a lot of steps. It goes real quick once you catch on to it. It's kind of confusing the first one or two times here. So to multiply matrices here, write the dimensions, make sure the columns from matrix 1 equal the rows from matrix 2. So like for example here, you have these are your rows right there. Here are your columns of the second. Okay, and then so you got 2 by 2 right here, and then you got 2 rows here, and then 3 columns going up here. So since the 2 and the 2 match up, we can multiply. So this result is going to be a 2 by 3. If you go look at this one right here, you're going to have a 2 by 3 matrix, and then the second one's a 2 by 2. And then since those middle terms don't match up, you can't multiply these. So actually now what we're going to do is actually multiply that first matrix, or the first set of matrices there together. So since we said the result was going to be a 2 by 3, we're going to actually make a 2 by 3 matrix here. We'll leave little blank spots, and we're going to start to fill those in. What I like to do here on these, and what I want you guys to do, is circle the rows on the first one and then circle the columns on the second matrix here. Okay, because that's going to kind of help us out here. And so what we do to do matrix multiplication is we take this 1 right here. It's going to be 1 times 5 right there. So that will go up here in this top left spot. Notice here, this is the top row left column right here. So this is going to go, all this information is going to go here in this top left. So 1 times 5 is 5. And then you're going to go and do 2 times 8, which gets us 16. Oh, whoops, 2 times 8. And then after that, then you're going to add your two numbers together, and that's going to get your result element right there. So that'll be 21 in that spot right there. Okay. And then you go through and you do all the different combinations here. So next, I mean, it doesn't matter on the order. I'm going to go this row times this column. So that's the top row, middle column. That'll go here in this second spot right there, since that's the top middle spot right there. So, and I'll color code it here just to kind of help us out here. So this is going to be 1 times 6, and then it's going to be 2 times 9. And then we're going to add those. So that'd be 6 plus, I guess, 18. And then if you want to add those afterwards, you're always going to add them afterwards. That's going to get us, I guess, 24. And it's kind of like a rinse and repeat. And usually I don't write this middle step out. Usually I'm going to, well, you'll see here in a second, but usually I'm just going to write 5 plus 16. I'll do some of the multiplication actually in my head. But just for our notes here, it's always good to write this down. Okay, so now let's go top row, the last column. So that's going to be 1 times 7, and then it's going to be 2 times 0. So that would be 7 and then plus 0 right there. 7 plus 0 will just be regular 7. Okay, let's go ahead and get that bottom row going here. Let's do, I guess, purple here. So bottom row here, you're going to go bottom row, left column. That'll go in the bottom left spot right here. So that's going to be this time 3 times 5. If it'll let me write. Which will get us 15. And then that's going to be 4 times the 8. Which will get us 32. That'll sum up to, what is that, 47? And we're good to go there after that. I guess I should circle all these to keep it consistent. Alright, let's go here. Bottom row, middle column. So we're going to go 3 times 6. And that'll get us 18. And then we're going to go 4 times 9, which is going to get us, get us our 36 right there. And if we add that, it'll be 54, I believe. So we do all that. And then last but not least, we'll do this last piece right here. I guess we're going to go brown. So now we're going to go bottom row and then right column. So that'll be 3 times 7. Which is equal to 21, and then 4 times 0. Okay, and then when you sum those up, that'll get us 21. And that is matrix multiplication. Pretty tricky at first here because it's kind of new, we hadn't seen it. The reason we're going to use this here is actually in a couple of lessons we're going to learn how to use matrix multiplication to solve systems of equations. We're going to use our graphing calculator for it, and it's going to make solving systems of equations very, very quick and easy. But we need to kind of understand what matrix multiplication is first. So, all right, let's do another example here, down here at the bottom. So first of all, we need to determine, can we multiply them? That's a 2 by 2 and a 2 by 2. So looks like we should be able to multiply them. The result, that R looks pretty bad. But the result will actually be the 2 by 2 here. 2 by 2. Okay. So we kind of know what it should look like here. And then, like I said earlier, we're going to take, if it'll let me write, there you go. So go rows, circle the rows of your first matrix, circle the columns of the second matrix. Okay. And then I'm going to list out all the different pieces here. Okay, so we're going to go for the top right row. We're going to go this times this right here. So 2 times 1 right there. 2 times 1, that'll be 2. And then 3 times, or negative 3 times 3 is going to be negative 9. So it's basically 2 plus negative 9 right there. And that'll be in that top left spot. And then actually I'm going to fill in all the blanks and then we'll simplify here in a second. Okay. It's kind of crazy here. Okay, so next we're going to go top row, right column. That'll go in the top right slot right there. So that's 2 times negative 4, that's negative 8. And then that's negative 3 times negative 2, that'll be positive 6. Right there. Okay. Next, we're going to go bottom row, left column. That's going to go in the bottom left slot right there. 3 times 1 is going to be 3. And then negative 2 times 3 is going to be negative 6. So plus, I guess, negative 6. Let me move that over a little bit. Okay. And then last but not least, we're going to go bottom row, right column. That'll be 3 times negative 4. That'll get us negative 12. And then negative 2 times negative 2, that'll be positive 4. Okay, and then all we got to do now is simplify that down to get our matrix. So that'll be negative 7, negative 2, negative 3, and looks like negative 8. So all of them happen to come out negative, but that's okay right there. So that would be your result right there. So got a few more here that we're going to try out. So let's see here. This first matrix here, let's make sure we can multiply it. That is 3 rows by 2 columns. And then this second matrix right here is 2 rows by 3 columns. So we need to determine, can we multiply them? We can. The result is actually going to be a 3 by 3. So this one's going to get a little crazy here just because we're going to have so much going on here. So 1, 2, 3. 1, 2, 3. So this is just for our work right here. Okay. And then circle the rows and columns. Actually, I'm going to keep that. I'm just going to move it. Okay, so there's row, 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 and then columns, columns, columns. Okay, so let's go start out here with top right, or top left, I'm sorry. 7 times 1 is 7. And then negative 1 times negative 1 is negative 1, actually. Okay. Next, whoops, let me delete that. Sorry, I'm struggling here. Okay. 1 times 0, which is nice, that's 0. And then negative 1 times 8 is negative 8. Of course, keep doing that. Okay, next you're going to go top right column right there. That's 4 times 1, that'll be 4. And then negative 1 times negative 5 will be positive 5. Okay, next we'll switch gears. We'll go to... We'll go to negative 2 times 7 is negative 14. 2 times 1 is 2. I'm highlighting just so you guys can kind of see where this is coming from. Obviously, you're not going to highlight every single one when you're doing it. Hopefully, you're doing it faster than me here. Negative 2 times 0 is 0. 2 times 8 is 16. See, there we go. All right, next we're going to go middle row, right column. So 4 times negative 2 is negative 8. And then 2 times negative 5 is negative 10. Long final row. So you got that row and that column right there. 3 times 7 is 21. 3 times negative 3 is, or 3, yeah, negative 3 times 1 is negative 3. Okay, 2 more. That'll be bottom row, middle column. So that'll be 0 times anything, which is once again 0. And then negative 3 times 8 is negative 24. Okay. And then let's see here. Got those. 3 times 4 is going to be 12. And then negative 3 times negative 5 is going to be positive 15. Alright, so that is actually the matrix. Now we just need to clean it up here. So it'll be a 3 by 3 matrix here. A lot of mental math here with these, and you are expected to do these without a calculator. I'm going to show you here in a second how to go multiply these without a with a calculator, just so you have it. Maybe that'll be good for checking your work if the answer key is not posted online. 16, negative 18, 21 and 3, so negative, what was that, negative 18, or actually, I'm sorry, positive 18 there. Negative 24 and positive 27. would be your result matrix right there. So a lot of work. Okay, let's see here with this one right here. Let's first of all just determine if we can multiply it. So that's 1 by 2, and this is 2 by 1. So you can multiply, and then your result. This is actually kind of strange here. The result's going to be a 1 by 1 matrix right here. Should be just like a single number inside. Alright. So here, really only got one thing to do. You got 0 times 3, which is, whoops, not 3, it's 0. And then you got negative 1 times 4, so that'd be plus negative 4, which results in negative 4 inside your matrix, and your 1 by 1 matrix. That is it right there on that. Now, D, got to be careful here on this one. Well, actually, no, I think this one comes out good here. What is this? This is a 2 by 3. Let's check it here. 2 rows, 3 columns. And then this is actually a 3 row and then 1 column right there. So those match up right there. The result is going to be the 2 by 1. Actually kind of nice. It's going to come out real good. First matrix, circle your rows. Second matrix, circle your column. Now this is weird. We haven't done something where there's like 3 elements in the first row, so this will look a little bit different here. But this will be a big long 2 by 1. So here you got to be kind of careful. You're going to go 4 times negative 2. Then you're going to go negative 2 times 3. And then you're going to go negative 7 times 5. So there's like 3 sets of things you're multiplying. So 4 times negative 2, that's negative 8. Negative 2 times 3 is negative 6. And negative 7 times 5 is negative 35. Okay, and then we'll add all those up here in just a second. Next one here, you're going to go all of this stuff now for the bottom, and then I guess middle column. So 6 times negative 2, that's negative 12. 3 times 3 is going to be 9. And then 5 times 5 is going to be the 25. And then we'll just use a little bit of mental math to clean that up. Let's see here. We have all negatives, I guess, in the top. So what do we got? Kind of doing this backwards. Was that 41? I think negative 49. I didn't mess up my mental math there. Yep, that's right. What we got here, negative 12 plus 9 is negative 3, and then negative 3 plus 25 should be 22 right there. So that should be your result matrix right there. Now, just so you guys have this as a reference, like so you know how to use your calculator to multiply 2 matrices here, I'm going to take this last example that we just did here, and I'm going to show you how to do it in a graphic calculator. So I'm going to kind of put this away to the side here. Maybe, I'm not sure if this will still show up here. I think it's going to disappear. Okay, so pretend you can still see it, or hopefully you got it on your notes here. But to do all of our matrix stuff right here, it's this blue option right here. You have to press the X raise the -1 button. So second X raise the -1 pulls up all the matrices stuff. Okay, now you can select any individual matrix on this screen. These are some of the different things you can do with the matrices. We'll get into that a little bit later. But then over here is where you can edit the matrices, which is what we're going to do. So this first matrix, we're going to call it matrix A. We're going to select that. You got to tell the dimensions. So the first one was a 2 by 3. So I'll hit 2, enter, 3, enter. And then you get to put in all of your elements. So you had 4, we had negative 2, we had negative 7, 6, 3, 5. Okay, so that's your first matrix. To get out of this screen, you're going to hit second mode right here, which quits you pretty much out of anything. And then second matrix again. And then scroll to edit. We got to edit our second matrix. So that'll be B right there. And then what do we got here? This one was a 3 by 1. Okay, and the elements were negative 2. Oh, you know what? So don't do the, what I did wrong there is accidentally hit the minus sign. which is on my keyboard. So make sure you do the negative 2, and that should come out good. So -2, 3, and 5. Okay, awesome. So then you hit second mode again. And then now we are actually going to tell our calculators to multiply these here. So if you want to go and hit second matrix, and then you're going to select matrix A, and you're just going to hit the times button, and then second matrix, and then matrix B there. And hopefully it comes out to the same thing that we got. That is exactly what we got earlier. Here, if I can pull it up. So notice there, -49, 22, so that was good to go right there. Now you can do anything with the matrices in your calculator. You can add, subtract, multiply. We don't really divide matrices, so that kind of messes up the calculator. But that's kind of useful there. Maybe it'll speed up some of the longer ones, like that one that resulted in the 3x3 matrix. I might have sped us up a little bit. But I do know that you're going to have to do a little bit of this without a graphing calculator. So it's very good to practice. It's good to use a calculator to check. Make sure you're getting your practice in on these. Okay. Next few here, I don't know. Yeah, okay, next few here, I guess we're going to evaluate here. We're going to do matrix A times the result of B minus C right here. So we're going to have a couple things. Now remember, to add or subtract matrices, they have to have the same exact dimension. So luckily B and C have the same exact dimension. So we're going to subtract those from each other. So I'm just going to put a minus sign there. And then 2 minus 2 will be 0 for that top left element. -3 minus 1 is going to be -4. We're going to go -1 minus 4, or minus -4 actually, which will change that to a +4. That should be 3 right there. And then 5 minus -2 should change to 5 plus 2. So that'll be 7 right there. And I guess I'll call this, I don't know, matrix X. Because now what we're going to do is we're going to do A times, I guess, our new matrix, whatever you want to call it, matrix X, I guess. Okay, so I'm going to write that down. 3, -2, 0, 4, -1, 5. Now we're going to multiply these. Once again, we need to make sure we can multiply them. So over here, you got a 3x2 column matrix, and then you got a 2x2 right here. So those do match up, so we are good to go. Our result matrix is going to be the 3x2. So result, say 3x2. Okay, cool. So let's do that. Circle rows, circle your columns, and then we're going to multiply. Okay, so if it's 3x2, it's going to look something kind of like this right here. Alright, so first up, we're going to have that top row times the left column. That's going to get us our top left slot. 3 times 0 is 0. -2 times 3 is -6. Okay, next let's go and, ooh, this is going to be tricky. Okay, I got it. Next we're going to multiply those two together right there. Actually, I got an idea. Okay, so 3 times -4 is going to get us -12. And then -2 times 7 is going to be -14. Remember, you're adding those. Okay. Alright, next, let's see if we can do this. Here we're going to go middle row, and then we're going to go left column right there. So 0 times 0 is 0. That's easy. And then 4 times 3 will be 12. Okay, next let's do the middle row left column, or I'm sorry, right column. So that's 0 times anything is 0. That's nice. And then you're going to 4 times 7, that'll be plus 28. Okay, next let's go and do this last row right here by that first column right there. So that'd be -1 times 0, that's 0 again. 3 times 5 right there is 15. And then let's finish up with the last row, the bottom row, in the right column. So -1 times -4 is +4. And then 5 times 7 is 35. to simplify. So that'll be negative 6, 12, 15. Those are nice and easy. Negative 12, negative 14. That should be negative 26, positive 28, and 39. And then this last one here, what is the solution of 3 times a matrix minus 2 times that matrix, and then equals this very last matrix? Okay, so I'm going to almost treat this like an algebra equation. We're going to distribute right here. And that's scalar multiplication. Notice when you have a number outside of a matrix, you just distribute. So it's a little bit different than what we have been doing today. So this will be, I guess, well, not. If we distribute the negative 2, this will change it to a plus. So this will be positive 2, negative 10, negative 14, and then 0 in the matrix. Okay. Next thing here is we're trying to get matrix X by itself. I guess I probably should use a capital X here, but matrix X by itself. First, we're going to subtract this matrix from both sides here. It's like algebra, except you're doing like a bunch of algebra questions at the same time here. And actually, here's what I'm going to put positive, negative 14, 0, but we're going to subtract that, so just don't, forget about your minus negatives. 2, negative 10, negative 14, and 0. Okay, so be kind of careful here. This matrix here, you're going to go 17 minus 2. Should get us 15. That's not too weird. But it's the minus negatives that you got to worry about. So negative 13 minus negative 10, which will change that to basically add 10. Negative 13 plus 10. That's negative 3. We're going to have negative 7 minus negative 14. Once again, it's kind of like adding. So negative 7 plus 14 should be 7. And then we're going to go 0 minus 0, which comes out to 0. That's pretty nice there. And that is apparently 3 times our matrix, which we don't know what the matrix is yet. All right, and then to get rid of this 3 out in front, we can go back and divide, or actually we're going to multiply everything by the fraction 1/3. So that'll be matrix, but we have to write it, I guess, on both sides. So that'll get us 5, negative 1, I guess the fraction 7 over 3, and then 0 divided by 3 is 0. And then this should be our result matrix right here. So it actually didn't use any of the stuff that we did today, but that's what your answer is right there.